This is VEX Robotics, probably the newest product, and it's been long anticipated. The first thing you want to ask yourself is why? Why VEX AIM? What's cool about this platform? Probably the first thing that I look at when I'm looking for a training platform is effectiveness. And that means engagement. If it's not engaging, the learners won't learn. It would behoove all of us that are in training or teaching to spend some time understanding the brain, the human brain, how it learns. And I think the key ingredient to long-term memory or remembering what you've heard and experienced is the level of emotion that you felt when you were learning it. Because at night when you go to sleep and you are unconscious, so to speak, your hippocampus, that's an element of your brain, a section of your brain, it takes the day's activities and it consolidates them into memories. It is the level of emotion that determines how strong the memory is going to be. If the learning platform is not engaging, then forget it. I mean, keep looking. Find something else. Number one, it has to be engaging. And then another big one is dollars. If you can't afford it, well, you got to keep looking to find the most engaging platform you can find with the dollars you got to spend. In this case, we're not talking about a single purchase. We're talking about dollars per learner. This unit, I believe right now, is $175 plus FedEx shipping. It's going to be a little over $200. But it's not just the one that you're going to purchase, but if you're planning on supporting a learning group, you need one of these for the most part for each learner, because there are some activities that it's going to take two of them, and we'll talk about all that. Probably the third is capability, features. And this little guy, VEX AIM, is got some really interesting features. And then, of course, potential. Is it extensible? And by extensible, I'm talking about add-ons. And as a controls engineer, and I started looking at the sensors on here, especially the camera, the video capability. The camera capabilities, I'm a certified vision system integrator. That means that I am certified by a manufacturer of vision systems to design, commission, program computerized vision systems that do inspection and manufacturing. As soon as I saw what they had already, that's already in one of the features, I got pretty excited about this. For me, potential or extensibility is how much further can they go with what they've got? What else can they attach to this? What kind of processing can they do offline to communicate with this robot? Because I really don't know what the desktop size is for this robot platform. Desktop, everybody's heard the term desktop for your laptop, your PC. And that came from the days when a worker, the original computer, and most of them were women working for the military, and they were called computers. And the desktop determined how many files you could open at one time on the desktop. You had a filing cabinet, and if you had a tiny desktop, then you could only pull out one file and open it up. Now, if you did something, you'd have to close up that file, put it away in the hard drive, the filing cabinet, and then pull out another one. With a larger desktop, you can pull out many files. Basically, the desktop would be the size of the memory. I don't have any idea how vast that is, but this VEX AIM definitely is engaging. The price is very reasonable. It's got a lot of features already, and the potential is there to extend it way out. Okay, VEX AIM, teaching hands-on computer science. That's the buzzword, I guess, computer science and hands-on, because when you're learning something, again, you need to study the brain if you haven't. Your optical system, your two retinas, which have 126 million photoreceptors each, and the two retinas travel through the nerve fibers to the back of your head, to your visual cortex. Some of them cross over. Some from this eye go to this side of the brain, and some from this eye to this side of the brain. And that's how you get stereoscopic vision. Experiential knowledge gained with a three-dimensional platform. In other words, you've got 3 dimensions because you're stereoscopic vision. It's not a flat screen learning. Okay, that's not 3 dimensions. But hands-on, besides, hand-eye coordination, it's also your stereoscopic vision. There's more emotion that improves quality of the learning. You can drive this VEX AIM robot with this little handheld controller, which means that the learners can start right out without any programming, and they can actually drive this little device around on the playing field and do things. They actually are learning or developing a process that later they're going to automate. Now, I'm a controls engineer, and I've got more than 40 years doing automation stuff. And I've kind of grown up through the thing from vacuum tubes to transistors to small-scale integrated circuits, etc. And we always say in our business, if you don't have a good process, don't automate it, because then you've automated a bad process. You still end up with a bad process, you just automated it. The learners driving this robot around, playing games with it, interacting with other students, little robots, playing tic-tac-toe or any other number of games that you can think of, they are actually developing three-dimensional processes in their head by using this handheld controller. This is the least expensive of all of the platforms that have a drivability 3 dimensions. And then this is also designed for the computer science classroom. The computer science classroom has been around for a while, for quite some time. I mean, my first programming language was Fortran, and we had to punch it in on punch cards, and then we took them to the big IBM computer, we stuck them in this slot and hit a button, they flew through there and then come out with an answer. Computer science classrooms have been around for a long time. This little guy was designed based on everything that VEX Robotics has learned with all their other products. They looked at the computer science classroom, and they says, what would work the best? They come up with a list of features and price, and voila, here we are. And then vision sensor, that's probably the most exciting feature on this robot. It can detect objects and April tags. I'm not going to explain what April tags are, you'll learn as you go. But objects, you can see there's barrels, a volleyball, and then there's these tags that are sitting there on the playing field. The vision system alone gives not infinite, but almost unlimited things that you can imagine. If you're a controls engineer, I can think of all kinds of things it can do. Right now the features aren't there to do, but it's extensible. And then comprehensive CS curriculum, computer science curriculum. This is just one example. Color code and kick. Use the button coding. Now remember, with 123, VEX123, all you had on the little robot was 5 buttons that you could punch in a sequence with and then start it. And then you could use the VEX coder with the little magnetic labels, and then you could use VEX code. This lesson right here is using the button coding on top of the VEX AIM, which has those same buttons because it's a color touchscreen. And these are the instructions for you to program to do. And I mean, there's hundreds of documents like this available for each of the VEX robotics platforms. Comprehensive CS curriculum. And then an introductory professional development course. VEX robotics, and this isn't for VEX AIM specific, it's just all their platforms. They have continually added documents and courses for you to do your professional development. Now, I'm not a public school teacher, but I do deliver lots of classroom training for major corporations, all PLC, VFD, HMI stuff. So I've got thousands of hours in the classroom in front of students, and I have a website where I sell 8 volumes on programming and troubleshooting for Rockwell Automation, Allen Bradley, PLCs, drives, HMIs. My professional development, I'm sure I'll gain something, and then there's also a PD Plus, but you have to pay for that. That's not free. But the introductory PD development, professional development, is free. Okay, VEX AIM, omnidirectional wheel, and you can see 2 of the wheels on the little robot, but here's a enlargement of one of the wheels. I don't know if it's the same brand, but it's the same type of wheel. And if you've not seen these before, if you look close, you can see that it can rotate on the axle and have 2 rows of contact. And if for some reason the robot goes sideways, the rollers on each of these sections roll, and there's always one in contact with the floor or the surface. They call it holonomic drivetrain, kind of like holographic, forward, backwards, sideways, diagonal. This is really cool. Multilingual color touch screen, display menu, sensor data, user text, and images. I just threw these up here to give you it's a color touch screen. Use your imagination. You've all been around color touch screens, and the one all the way over on the left, that's what you basically saw when you were using VEX123, and that was the button coding. When they say button coding, that's what they're talking about. Forward, rotate left, rotate right, make a sound, and then the start-stop button in the middle. It says VEX. And then we have user-controlled speaker, enhanced interaction with selectable sounds. I put an example up here from their instruction set, or they call them programming blocks. Play sound. You can drop down a list and pick a sound. Play sound file. You can drop down a list and pick the file number, and these are custom sound files that you uploaded. You can actually add your own. You could take your favorite song and take a little strain of it and record it and then import it. When it does certain things, it plays a custom sound. Play notes. If you're into music at all, you recognize this. And then, of course, stop sound and a conditional where in your program you can say if the sound is active, or you can say not active, because if you know about your operators that are available, it can be if sound active, and you can do if not sound active in another way. And then precise navigation. It includes a gyro, accelerometer, and wheel encoders. Wheel encoders, in my business, if you have a motor, you have motion, we typically like servos with absolute encoders, like Stegman encoders. You probably don't know what that is, but we like servos, and we like an encoder that never loses its position. But basically with the other products, the older ones, in this price range, the robot had no idea where it was at. Whereas if you have encoders, then the processor can look at the count from those encoders and determine exactly where it's at in relationship to where it started. Now, the difference between a gyro and accelerometer, I always think of accelerometers as a type of gyro because they are sensitive to inertia. Wheel encoders, that's a big one. And then programmable LED lights, that just adds a little engaging visual experience. Remember, I told you my key criteria is that it be engaging. Okay, it's also got robot-to-robot communication enabled via Bluetooth for interactive learning. I threw up 3 instructions here. I call it an instruction set, but it's programming blocks. When I receive, then you can select what you receive from the other robot. And if you want to send out something, you can broadcast and select my event or drop down a list. And then you've got another one which is similar, but and wait. That right there ought to give you goosebumps, imagining what you can do with, like in a competition, or rather, I prefer the term cooperation. One of my favorite physicists, Federico Fagin, he had this amazing quantum experience outside of the classical world. And he said once he went through that, he could no longer compete. He could only cooperate. I've been a cooperator my whole life. I'm competitive in a sense, but I'm always looking to cooperate, because if one person can set 1,000 to flight, two can set 10,000. That's an order of magnitude in effectiveness when you cooperate. Imagining what you can do cooperatively. You could do battle bots, which would be compete, but you could also have teams that have to work together with their programs between the robots to cooperate to accomplish something. Very exciting. Versatile coding options. They show Block, Switch, Python, and Visual Studio Code with VEX extension. Visual Studio Code, that's just another development environment for Python. Now, right now, C++ doesn't show for this product. But if you learn Python, C++ is just in another doorway in the same room. If you want to say Python is the first bedroom, then you go out and go in the second bedroom, you're already there. It's easy to learn. What you're seeing here is you're seeing block programming. When started, show a happy face on top of the AIM, looking and then looking forward. Okay? In other words, you can determine what image shows up on the screen on top of VEX AIM, and you can tell it which way it's aiming, whether it's looking backwards, forwards, sideways, or what. And then adjacent to that, to the right, is the exact same thing, but it's showing the Python code. And if you use switch, then you can switch the instructions over. See the blue turn right until ball found over on the left, right underneath show looking forward. That's exact same code, but in text instead of a graphic. With VEX AIM, remember I said extensible. I can't speak for VEX that they're going to add C++, but it seems reasonable that they could. Convenient program downloading, by Bluetooth or USB cable. Rechargeable battery, that's good. Notice the on-off button right below the port. Okay, now here's what you get in the kit. Now remember I told you the kit's about $175 plus FedEx shipping. Now I wanted to show you this before we continued on to show you some other things. So you get these little barrels that the VEX robot, the AIM, can interact with, and you got a couple soccer balls, you got a USB-C cable, and then you got the hand controller. Now the vision sensor can detect pre-trained objects. Now that should get your imagination rolling. Can I train objects? In other words, can I record objects and identify them? I can look for them later. I don't know. I haven't tried that yet to see what the limit is of detecting pre-trained objects, because it's pre-trained by VEX, or can I add trained objects, such as balls, barrels that come with a kit and other AIM robots. Right now it looks like you can only recognize certain things. It can detect colors, combinations of colors, and April tags. Now I'm not going to go into April tags, but that's kind of like a 3D barcode of some sort, and almost unlimited potential with this. You can code the robot to turn to the ball, then get the ball, and see how you can also see how the vision sensor is working to accomplish the task. There is some code that's viewable. Then when you're ready, you can explore exactly how the robot is using sensor data to accomplish this task. Okay, why VEX AIM? I started out and did that. I'm going to back up and give you some more. This was VEX123. You got this little 3-inch puck, and you can program it with the buttons on top. And this is good for pre-K and kindergarten. It really is, because less is more. They can't get confused if they've only got 5 buttons. Forward, rotate right, rotate left, and make a sound. And then a start button. Then, once they get to developing a little process in their head, in order to keep track of the steps, because you can write out the steps, forward, 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 because it only moves about 3 inches for each time you push that green button with the arrow on it. you have to learn kind of how to sequence things to move around on the playing field. Once you do that, then you can step up to the VEX coder. That's the handheld that you slide in these little magnetic cards, and then there's a green button on top there that you push, and that starts the program in the little blue puck. It's also got a single step orange button and a stop button. Then once they've gotten comfortable using those command strips or program block strips, then they can go into VEX code. And VEX code on the laptop there, VEX code 123 is a stripped down version of VEX code. It's stripped down to only let the learner see just what they can use with that little blue puck. And then of course there's VEXGO. And VEXGO uses the same VEX code, but it has a little bit more. It's VEX code Go instead of VEX code 123. Again, it's a stripped down version, but its capability and instruction set are context sensitive to the fact that this little robot can only do certain things. The big thing about this particular one over 123 is spatial reasoning. Although with 123 they were spatially reasoning the playing field, movement about with, and remember, we're talking 1, 2, 3 and go now. We're not talking about AIM anymore. We're talking about the older platforms. The spatial reasoning for this one above 1, 2, 3 is that you have to snap together parts. You have to look at visual instructions, on a piece of paper or on a screen. You have to follow the instructions to put together things. Besides spatial reasoning, also hand-eye coordination. Again, the more of your senses that you use when you learn, the stronger the memory. If you're just sitting looking at a flat screen, you're not going to learn as much as if you're looking at a 3D live and you're touching it, feeling it, interacting with it. The only thing you really don't do with the VEX robotics is taste and smell. But you got all the other senses. The other 5 senses are involved, including sound. It's because they do make a sound, they make clicks, and the surfaces rubbing together make sounds. There is a little bit richer interaction with these platforms that you snap together or you assemble. Here you see the code base up there at the top. It's just got 4 wheels. The downside of this is when it turns, when it rotates, we'll say, the 2 front wheels with the black tires, they rotate opposite directions. So it rotates kind of like a tank in place, which means it has to drag the back wheel or back wheels. They have one of the code bases only has 1 wheel in the middle and the back. That's less friction to drag. And I forgot to mention 1, 2, 3 on the bottom has 2 wheels, but to balance it, it has 2 bumps. Anytime it's moving across the playing field, it's being held stable by 2 bumps that are dragging on the surface, with friction, and it can displace its path and lead to your robot getting off into the ozone, into the weeds, and it's not what you program. Also with the VEXGO and hand-eye coordination, you also have gears. So you see there, they've got a little lift gate or something. You run the motor to lift the draw gate up and down. There's, and then the drive base there, the code base. There's some you can build that have gear ratios, so you can change the gear ratios, and you can actually mathematically calculate the effect that the different gear ratios are going to have. VEXGO can't be ruled out simply because it has better spatial reasoning and hand-eye coordination skill development. And then the other, what we'll call spatial reasoning, hand-eye coordination, would be VEXIQ. This is a little bit more complex construction. It has more capabilities than the VEXGO. But the draw here for both the Go and the IQ is the hand-eye coordination and visual reasoning. Another thing, and notice the back wheels on this guy are those omnidirectional wheels. When you rotate by, having the front 2 wheels go in opposite directions, it's not as much friction fighting the rotation. One thing I did notice about VEXGO and IQ is that they do have some sense of angle of rotation, because when I told them to rotate right or left, they'd stop and then they'd back up a little bit. They'd rotate to the left and then stop and back up a tiny bit. They kind of knew they overshot. Now that's one of the drawbacks of these you put it together robots instead of it comes pre-assembled and dialed in like the VEX AIM. Okay, again, why VEX AIM? If you look here at the first 6 platforms in their list, and they've got 8 or 9, I cut it off here at 6 because it goes from grades pre-kindergarten up to grades 9 through university. VEX V5, they consider that going into the university, and I actually have friends that use VEX V5 in their classroom in universities. Professors that I've known for years that I work with, actually these professors use my PLC training manuals in their classes. If we look at the difference between these, you can see that VEX123, you don't build anything, but VEXGO you do. VEX AIM, you don't build anything. VEXIQ, EXP, and V5 and forth, you all have to build things. But one of the biggest differences, I guess, would be how you code these devices. With VEX123, you've got block coding. With VEXGO, you went from having from block coding to also you have to assemble it. You have to build the robot. That's going to add a degree of undeterministic results, because if they don't snap it together right, and another good thing about these, you put it together like VEXGO and IQ, is you kind of learn that you can do a perfect program, but the real world's going to get in your way. It's going to mess up what you did. Well, then we get to VEX AIM, the one we're talking about today, blocks and Python. That's a biggie. I can do block programming. I can do actually button programming on the top of it, on the touch screen. I can do blocks and I can do Python. VEXIQ is blocks, Python, and C++. And you see that the blocks, Python, C++ pretty much goes the rest of the distance through their platforms. Now there is one other small difference, and that is that the VEX123 had card coding. Okay? Now the VEX AIM has card coding, which it has button coding, which they didn't put in the list there. They just said blocks and Python, but it's really button, blocks, and Python. Don't forget that with the VEX AIM, you get the buttons, blocks, and Python. With 123, you get buttons, card coding, and block coding. Now, let's look at some of the things that you can do with VEX AIM right off the bat. Using the handheld controller, the little joystick, you can play a game called Barrel Knockdown. Drive the robot to pick up a sports ball and kick it to knock down a stacked barrel pyramid. So you see the grinning robot goes over, picks up the yellow ball, rotates, aims at that stack of barrels, and kicks it to knock it down. Now this is with the controller. You don't program this. Then you got barrel tic-tac-toe, but this takes 2 robots. So you see one robot's got 5 orange and the other's got 5 blue, and they just play tic-tac-toe. And if you don't know how to play tic-tac-toe, I guess this is irrelevant. And then button coding. Now we stepped up here. We left the hand drive, in other words, driving with the little handheld. Now we're going to programming with the buttons. Now you can do a lot of this in block coding and Python, but I'm just kind of showing you the sequence of where you start with just driving it, and then you step up to button coding. Use button coding to move the VEX AIM robot to arrange the barrels by color as quickly as possible. Now you're doing this with button coding. And then there's another one here, match and displace. Use the button coding to move the robot to deliver numbered barrels to the matching April tag ID. Your April tags are 1, 2, 3, 4, 0, 1, 2, 3, 4, because remember, in computers, everything starts with 0. The first 5 is 0 through 4. And then notice that you've got 0, 1, 2, 3, 4 as far as the barrels go. That means the robot then, through button coding, now this is really a pretty complex challenge, it has to find, it goes, let's say it goes and picks up 2, the little orange 2. Then it has to start looking for April tag 2, which is the kind of the purple burgundy 2 straight across the playing field. You could say that it goes straight forward, grabs 2, and then goes forward again and drops it off at 2. Then it can rotate to the right, pick up 1, rotate around 180 and drive it up and drop it off at 1, and forth. That video was too long. We're going to stop right here. This is enough to whet your appetite. Remember, I'm not trying to sell you VEX robotics. I'm not teaching a course on VEX robotics. I'm just sharing my enthusiasm for this product to get you involved with STEM education in your environment, in your community. So I will be back and do some more VEX AIM because I'm excited about this guy, and we'll see you in the next one.